Hi folks, and welcome back to Math with Captain Rod here. I'm making this to be video 2 here of a set on graphing parabolas. So we're going to sketch a graph of this one here, y equals minus x squared plus 2x minus 3. All right, first an important observation. This is going to open down because it's in the form y equals, and the number in front of the x squared term is negative. First thing we'll do is go after the coordinates of the vertex. The x coordinate, oh, what happened there? Okay. Sorry about that. All right. So the x coordinate of the vertex we get by minus b over twice a. In this example, let's see, minus b is 2 over 2 times a, which is minus 1. So you'll notice the minuses, these are going to cancel, and 2 over 2 is 1. So the x-coordinate of the vertex is 1. That's a nice, easy number to work with. All right, the y-coordinate of the vertex, we'll go ahead and plug that into this equation here. So that's going to be negative, all right, 1 squared. Now this minus sign is in front of the x, so that's not being squared, plus 2 times 1 minus 3. All right, let's see what we get out of that. So this is going to be negative 1 plus 2 minus 3. And what do we get out of that here? 1 minus 3. Looks like negative 2. So the vertex of this animal is at the point 1 minus 2. So we go 1 and then 2 down, put a dot. Now, we know this thing's going to open down, so it's going to look something like this. The y-intercept would be a nice, easy point to grab. If x is equal to 0, y is going to equal, right, 0 minus 0 squared, if I write this out, plus 2 times 0 minus 3. And you notice, right, that's a 0, that's a 0, right, negative 3. So 0 and 1, 2, 3. Now remember, these things are symmetric. Right, here's the vertex. We know it opens down. It's going to be symmetric about this line. This is the line x equals 1. So that means if I go left and down 1, there's going to be another point, right and down 1. And you can check this. I'll leave this to an exercise for the reader here, or watcher. If you put in x equals 2 into this, you should get out negative 3. And let's grab one more point here just to get a numerical, or get us a little more of this graph. Let's grab one at, let's see, 1, 2, let's grab 3 here. So if we put x equals 3 into this equation, and if you don't mind, I'm going to do this. Minus, and 3 squared is 9, minus 9, plus 2 times 3 would be plus 6, and then minus 3. And that comes out to be negative 6. So again, if x were 3, I don't know why that did that, 3, x were 3, y is equal to minus 6. So 1, 2, 3, minus 6, 1, 2, 3, 4, 5, 6. Now remember, these are symmetric. So if we go from, whoops, I wonder if that's going to let me back that off there. Darn it. It did, but it jumped the graph. Okay, there we are. All right, so if we go 1, 2 over, 1, 2, 3, 4 down, we should be able to go 2 over and 4 down. There's another point. Okay, that's probably enough here. Let me sketch this. Again, this is just a sketch. There's our parabola. It looks something like this. Good enough. Okay, let's talk domain. And domain, there we go, D-O-M-A-I-N. I always give the advice for this when finding the domain of algebraic functions here. All right, you take a look at the original and start by assuming all real numbers, then you look for problems, and the problems that will occur: division by zeros and square root of negative numbers, or, by the way, any even root of a negative number. These will give you problems. Can't do those operations. So neither of these are here, so the domain is all real numbers. You put anything into that function you want, you're going to get an answer out. Okay, let's talk range. All right, you'll notice there's no y values up here. The only y values we see are down here. That one right here is, let's see, y equals -2. They are all smaller than that, so we'll just say y has to be less than or equal to -2. Or, I usually just give my values like this in set notation. Here's what it would look like. The set of all y such that y is less than or equal to -2. I consider either of these acceptable. So, and I'm going to go ahead and call that one done. Let's see what we got below. Okay, one more. Looks like that one probably opens to the left, right? So it's in the form x equals, so it's going to open, horizontally. The a is negative, so it's going to open to the left. First thing we want to do, let's get the y-coordinate of the vertex. Minus b over 2a. So if you don't mind, I'm going to write that -2 over twice a, and a is -1, so that's going to be over -1. Oops, I'm sorry, -2 twice a, which is equal to 1. Nice easy value to work with. That's nice. To get the x-coordinate of the vertex, let's take this value, plug it back in here. So this is going to be -1 squared. Now that minus is not being squared because it's out in front. Plus 2 times 1, and then -3. So let's see, -1 plus 2 minus 3. That's 1 minus 3, that's -2. All right. So the x-coordinate of the vertex is -2, the y-coordinate is 1. So 1, 2, 1. There we go. Now we know that this thing's going to open to the left, so it's going to look something like this. It's also going to be symmetric about this line. There's our axis of symmetry, and that's y equals 1. Let's go ahead and get the x-intercept. We can get that easy enough by putting 0 in for y. Why this does not work as well as I would like. All right, so if y is 0, x is going to be, right, this term will be a 0, this term will be a 0, and that will be a -3. So this goes through the point -3, 0. 1, 2, 3, 0. Now remember, it's also symmetric about this line. So it's also going to go through -3, 2. And the way you can check that here, 1, 2, 3. If you run a -3 here and solve for y, you'll get those two values. Let's get about one more point over here somewhere. Let's see, 1, 2, 3, 4, 5. Let's do 6. Let's put -6 in for x and get a pair of values out for y. So that's going to be -6 equals -y squared plus 2y minus 3. So this is going to be 0 equals, adding 6 to both sides, minus y squared plus 2y plus 3. Just double check that, plus and plus, yep. Let's multiply this by -1, just because. And let's see, any chance that factors? 0 equals, does that factor in a y minus 3? Y plus 1, let me double check that. Y squared minus 3y plus y, there's my minus 2y minus 3. Okay, I was lucky, I picked a value where this thing's going to factor. So this has a solution of y equals 3 or y equals minus 1. Again, that was a 1. Alright, so what did we do here? We did if x is -6, then y is either 3 or minus 1. So 1, 2, 3, 4, 5, 6. -1 or 3. 1, 2, 3. That's enough here. Let's just sketch our parabola. Good enough. All right, our parabola is symmetric about y equals 1, opens to the left. Although it's not a function, it doesn't pass the vertical line test, so I wouldn't call this a domain, but I would say this. The values of x that will yield solutions, real solutions of this equation here. Let's see, x less than or equal to -2, and then y values that will come out, all reals. And again, I wouldn't call this a domain and range. This thing is not a function, but these are the values of x that will yield you solutions for y. If you put in a value, say x equals 0 into this, what will happen is you'll get imaginary or complex solutions. So let's see. I guess we're going on 10 minutes. That's long enough. This was just meant to be second video here on to provide examples of how to graph parabolas. I hope that this helps. Have a great day.